All right, well, this will probably be a quick little video because I don't have a lot to say. I'm actually kind of embarrassed that I even have to make this video, but it's going to be about a small tweak that I figured out how to make to the code of this little device to make it just work a lot better, primarily by just sorting out how the display updates to just make it all faster. So if you didn't see my previous videos, this is just a little thermal probe that I made to monitor chamber temperatures and things like that in a rifle. And I thought whenever I was making this that I would really just use it for like one test that I wanted to do. And so I really kind of threw it together as quick as I could for the most part. I was a little careful, but not really careful in optimizing everything. As it turns out, this is actually pretty handy, even for non-testing purposes, like, getting ready for hunting season. And one of the things about hunting is you basically only take one shot. And so it's very important to have your rifle zeroed at a cold barrel temperature. Basically, you don't want to zero with long string of fire because, well, that does not replicate the single shot that you're going to be taking on an unwarmed, unfired barrel, to try to accomplish a hunt. And so in order to do that, you zero over a sequence of shots that are taken with the rifle in a cold state. But the nice thing about having this is I can actually check and verify exactly how cold or warm the barrel is with my probes. And so I was able to go out and zero pretty quickly because I know now exactly how long I need to wait before I take another shot because I can verify, yep, chamber's cold. Anyway, so in that process, one of the things that I found annoying about this thing is how slow it updates. You can see that temperature just blink in there. Now, if I turn it on, this is where you'll really see how slow this thing updates. So it comes on, and now you'll see these temperatures slowly trending down to their actual temperature. And that's because I use a rolling average for these temperatures. It's a 10 sample average, but those samples are supposed to be being taken 100 times a second, and the display is supposed to update 10 times a second. And it's just not. It's just way slower than that, and I was getting very frustrated by that. And so I started looking through the code thinking something is unoptimized. It's running the update routines in a stupid sequence. Something's just got to be jacked up. And so I was working with ChatGPT because I was thinking maybe this is a good place where AI can really help just take a simple problem and just fix it. And ChatGPT and I went back and forth for a couple hours where it recommended a bunch of really probably good optimizations, but they were really going the wrong direction and it wasn't able to accomplish those solutions very well in code. And I finally just reverted all the way back to the base code because I'm like, all right, ChatGPT, you're not hacking it. So I started over with a totally different question, which was, hey, isn't this thing using software SPI and isn't there a way to force it to use hardware SPI? Because, like, I know it's an ESP32. There is no reason that it can't drive this display at a very fast refresh rate, and the calculations to do 5 rolling averages at a sample rate that slow, this should not tax this type of microcontroller. It's just way too powerful for me to be seeing this kind of crappy performance. And it turns out, yeah, I can just force this thing to use hardware SPI. Now, the original problem why I wasn't using hardware SPI in the first place is because this is this Lilygo TTGO built-in display board, and it's hardwired, and it does not use the default SPI pins. And so if you use the regular setups for SPI, it won't work. You have to use software SPI. And I was like, isn't there a way to tell it to just use different pins? And sure enough, there is, and it's dirt simple. And so let me show you the difference that it makes going from software SPI to hardware SPI. And so let me just plug this thing in and let me update firmware. Okay, so you'll see it change in just a second. All right, so it's uploading now. and just bam, right? You see how all of the temperatures just immediately pop on. And if I touch one of these probes, yeah, they update just much quicker now. And so let me unplug this. And so let me show you now from startup how long it takes for everything to stabilize. So turn it off, turn it back on. And you see it's just bang, right? This thing is just immediate now. And if I touch one of these other probes, you can see all these temperatures and they just immediately react, right? And the display immediately reacts. So hardware SPI is the way to go. And I'll show you how to modify the code. It's dirt simple. I'll upload the new sketch. It's literally 3 lines of code to make this work. And they're not complicated. It's literally just declaring, hey, do this SPI device on these pins, use it, right? I mean, that's basically all you're doing. Now, just for your information, basic ESP32 has 4 hardware SPI interfaces. It uses 2 of them on board for like memory and stuff. You have 2 usable SPI interfaces. So basically there's one called HSPI and one called VSPI, or on the newer boards, I think it's called FSPI. But basically you just pick one, tell it, hey, use this thing. Here's the pins I've got it wired on. You got to make sure that you're using pins that are capable of using the SPI bus. But past that, boom, it just works. So let's move over and we'll look at the code and we'll show you just a few lines of code you got to add to use or force a hardware SPI interface. All right, so here's the base code for this project. And so, like I said, we're going to force this thing to use hardware SPI. And it turns out it's very easy to do that for one of the ESP32 boards. So the first thing we need to do is at the top into our includes, we are going to add the SPI.h. And so basically we're just going to enable the SPI protocol in Arduino. Then next up, we're going to scroll down to where I've defined everything for the software SPI interface. And we need to make a couple changes here. So the first thing we need to do is we're going to initiate an SPI class. So SPI class. And then we have to pick a name, and so I'm going to call this HSPI. You can name it anything you want. If you want to call this thing Dave, you can call it Dave, but I'm going to call it HSPI. So then I have to tell it what SPI bus on the device do I want to use. Now, on an older ESP32, you have 2 choices, either HSPI or VSPI. Either one of those will work. Now, if you're on one of the newer boards, I think, like a S2 or an S3, I believe they don't have the VSPI. I think they've renamed it to FSPI. So like FSPI, if you're on one of the newer ones, would be the other one. But since I want this to work on as many boards as possible, all of the ESP32 chips should have HSPI bus. Okay, so then we now need to modify our ST7789 code here because we don't need to tell it everything in here anymore. So the first thing we're going to do is at the front, I'm going to say and HSPI. Now what this is it's saying use this bus right here. So the name here, this HSPI, is actually because I named my class HSPI. So I'm saying, hey, use this class that I've defined up here. Next up, I'm going to remove the master out serial in and the serial clock, because whenever you're defining the SPI like this, you don't put those there. It will break the code. Now we only have one more change, and so I'm going to scroll down into the setup right below where I start the serial interface. So right here, after I begin the serial communication, I say, all right, begin using the SPI interface, the SPI class that I've already set up. So I say begin, should be begin. All right, so begin using this interface that I've set up, using this for the serial clock pin. It will next ask about master in serial out, and since we won't be using that because the display will not be talking back we're just going to say -1. That will say we're not using that pin. Then we say TFT MOSI. By the way, these are just references to these definitions so that I'm telling it, hey, here's what these pins are. Last one, TFT CS. Then we need a little semicolon there. And that's it. That's all the code needs to change in order to use the hardware SPI. And so overall, all we're doing is basically up here saying, hey, make sure that we've got the SPI header file pulled in. Down here where we define out our interface, we need to create an SPI class to use the hardware SPI that the board has available. We need to change our little driver here to say, hey, make sure you're using that new SPI interface whenever you do your stuff. And then down here during setup, we just need to make sure that that new SPI class is started up and running whenever we run our code. And that's it. Now it will use hardware SPI and be much faster. All right, so that's going to wrap it up. Again, not much to say, quick video. I just thought I would show you the difference that using hardware SPI can make. So, you know, and I also thought, you know, if anybody's using one of these boards and you want to see an example of forcing it to use hardware SPI, it's useful to know that these options exist because it is so powerful. It's ridiculous to not be using hardware SPI when you can, because the performance is just night and day. So anyway, if you got any questions or feedback, you know, as always, feel free to leave a comment down below.